Hello everyone, this is a video explaining boundedness. So a function can be bounded above, bounded below, bounded above and below, and unbounded. So bounded above, sometimes we say bounded from above. And we think about that informally as a ceiling, something you can't exceed. So for example, f of x is equal to negative x squared, that graph has a maximum, it has an upper bound. Your graph is never going to go above 0. Algebraically, we would say that for this function, f of x is less than or equal to m, and in this case, that m is 0. So that's bounded from above, or bounded above. Bounded below, or again, sometimes we say bounded from below, is when informally we say there's a floor to the function. So f of x is greater than or equal to m. Every part of the function is at or above a certain value of y. So for example, f of x is equal to x squared. That graph is bounded, or the function is bounded from below. There's a floor to it. It never goes below 0. Bounded above and below, as you might expect, would be both. There's some value m for which the absolute value of the function is less than or equal to m. So one example is sine of x, right? Because there's an upper bound of 1 and a lower bound of 1. So it's bounded from below and it's bounded from above. So you see informally, again, we think about that as there being a floor and a ceiling. And last but not least, unbounded, which is neither. It's bounded, it's not bounded above, it's not bounded below, it's not bounded at all. So one example is x cubed, because your graph doesn't have a minimum or a maximum. It just keeps, its range is all real numbers. So you don't have any restrictions of your range whatsoever, and it's completely unbounded. So what you can do now is you can go to Desmos and you can try separately, try x to the 4th, negative x to the 4th, cosine of x, and 1 over x, and see if they're bounded from above, below, both, or neither. Thank you.